Okay, so today we're going to keep on talking about trigonometry. So remember, when I'm talking about trigonometry, I'm talking about triangles. And so what makes triangles special is the 1, 2, 3 angles. Remember, tri meaning 3. So 3 angles make up a triangle. So when we're talking about trigonometry, we're talking about relationships. So how the sides and angles work together, and how we can use those to find missing pieces of information. Because if there's a relationship there, just like in a line, if we know some of the pieces, we can find the missing pieces as long as that relationship is consistent. So you can use trigonometry for any triangle, no matter what size or shape it is. But for the ones that we're going to look at, kind of the initial intro trigonometry triangles, we focus specifically on right angles. And so when I say a right angle, I'm talking about a 90-degree angle. So we're specifically talking about triangles that contain a 90-degree angle. And remember, it could be down here. If our triangle was like this instead, it might be up there. We could have a triangle like this with it up here, or like this with down there. Doesn't matter where the angle is, as long as there is one 90-degree angle. It is a right triangle, and so we can use these trigonometry relationships that we've been talking about. So the one we talked about last day was Pythagoras. So remember, for Pythagoras, the side across was c, and then we had a and b, and it said that c squared was equal to a squared plus b squared. So with Pythagoras, we can find a missing side if we know the two other sides. Right? So as long as we know 2 out of the 3, we can find the third. But not all triangles are going to give you 2 of the sides. And you're not always going to be looking for a side. Maybe sometimes you want to find an angle. So we need other relationships there as well to fully solve these triangles. And so the next ones that we're going to talk about here are what we call the trigonometric ratios. And we're talking about the basic ones first. There's a lot of more advanced ones that build off of these same rules. But to start off with, we're going to talk about 3. So we have sine, cosine, and tangent. And essentially, they're just different relationships based on the information that we have. So depending on what you know, you can find different things. And we use different ratios depending on what we know. So we can use these to find missing sides. If we know an angle and a side. So we always need kind of 2 pieces of information to find the third. So we can also find a missing angle if we know 2 sides. All right, so I kind of use these in 2 different ways. So for today, we're going to kind of focus mainly on using the calculator. Instead of actually solving triangles, we're just going to be kind of looking at the precursor. And then next week, we'll look at actually using these ratios to solve problems. So for today, we're going to get used to our calculators and get used to actually setting up the ratios so that next day we can use it to solve. So we are kind of using that CAB like we did with Pythagoras, but we switch up the language a little bit. So your C is still, it's always going to be the hypotenuse. And remember, your hypotenuse is your side that is opposite the 90-degree angle. So opposite that right angle. So wherever you see that square, that's going to be your hypotenuse. So for both of these triangles, that's your hypotenuse. Now for the opposite and the adjacent, they change depending on what angle we're looking at, because they are opposite and adjacent to a specific angle in the triangle. So for this first one, we're going to look at this one, which we're going to call A. This is going to be triangle A, B, C, and this will be A, B, C. So in this first triangle, we're going to be looking at angle A, and in this second triangle, we're going to be looking at angle B. So for both of them, the hypotenuse is going to be across from the right angle. So that's always going to be the same, just like with Pythagoras, always the same. The ones that change are your adjacent and your opposite. So adjacent means beside, and opposite is across. And they're both in relation. So both of these are in relation to the missing angle. So in this case, the angle that I'm looking for is angle A. So that's the one that I'm going to reference my adjacent and my opposite to. So your adjacent is going to be connected, right? Attached, beside. So this is going to be your adjacent. And then the opposite is opposite or across. So across from that angle is going to be your opposite. So being able to label these sides is really what's going to make the difference here. Once you can label the sides, these ratios become really easy. So this time we're switching it up. Instead of looking for A, we're going to be looking for angle B here. Hypotenuse stays the same, but this time, this side is attached. So that's now going to be the adjacent. And if we look across from that angle, this is now going to be our opposite. So it all depends. It's all in reference to the angle that we're looking for. So we're going to be doing a lot of calculator work here. So it's really important that you have a calculator that you're going to use every time, because every calculator is going to do this a little bit differently. And it's just kind of a pain to have to figure it out every time because they look a lot different. So on your calculator, I pulled up 3 different calculators here so that we can kind of see what the difference is. So the first one we're going to look at is just an internet calculator. So I just pulled up a scientific calculator. So what we're looking for are those trigonometric ratios. So if you look on the calculator down here, we see sine, cosine, and tangent. So those are our trig ratios. On my computer calculator, same thing, but they're going to be in a different spot. So I've got sine, cosine, and tangent. And then I also have this, though this is more similar to a calculator you'd have on hand, but the same thing. Sine, cosine, and tangent. So those are the ratios we're going to be working with here. So to use these buttons, once again, it's going to be different depending on the calculator you're working with. So in a traditional scientific calculator, you're usually going to press the trig button first and then put the angle in. What this is going to do is it's going to help us find the ratio, so the relationship, which if we know one of the other sides, we can use to figure out what the missing side is going to be. We're going to use that more next day. For today, we're kind of just practicing using those calculators. So if I'm trying to figure out tan 15 on my scientific calculator, my first step is I press the tan button, and you'll see it pop up on the screen there. So I go tan 15, and then we close off that bracket. You don't have to close off the bracket, but it's a good habit to get into. So if we go tan 15, my answer is negative, does not stay up, good to know, 8.855. And we're going to 3 decimal places, which means I need to look and see if I need to round. So from that 5, I'm looking at the next number, which is a 9. Because that's higher than 5, I'm going to round up. So negative 0.856. Okay, so let's try tan 35. So we're going to use a different calculator this time. Now on this computer calculator, and this is probably, actually don't, going to be similar to like if you're using a phone calculator. Ooh, I need to clear it. There it is. We're going to press the angle first and then press the button. So here we're going to go 35 and then 10. And you'll see it shows up in the bracket there as the same it did on the other calculator, but we have to put it in backwards. So it's really important you know what type of calculator you're using. And generally the rule that I follow if I'm trying to figure this out is if I have a working screen, so notice on this one that as I'm working, I can see on the screen what I'm doing. Those ones usually you press the button and then the angle. But on this one, where I'm just pressing the buttons and I don't have a working screen, it doesn't track what I'm doing, often you have to do it backwards. So here tan 35 is 0.700, and we're going to look at that 2, smaller than 5, so I'm going to leave it at 0. So this is 0.700. And tan 5. So we're going to try this internet calculator for the last one here. So this one, I believe, has a working screen just like my other one. Yes, you see how when I press tan, it comes up with a bracket? That's kind of a sign that we're going to be button first and then put the number into the calculator. So tan 5, and then close that bracket. So my answers show up on the other side here. So 0.087, and I'm going to look to the 4, smaller than 5, so that 7 is going to stay true. So 0.087. Okay, so for tan functions, kind of makes sense. We're going to use the tan button, which means that for sine functions, probably going to use the sine button. So I'm going to go sine 35. Oops. We need to clear it first. Clear all. Sine 35. And it shows up there, 0.573. And because the 5 or bigger, we're going to round up. So this is going to be 0.574. All right, so let's try the scientific calculator. So remember that for this calculator, it was a little bit different. For this calculator, I had to put the number first and then press sine. So I go 29 and then press sine. 0.48. And I got to look to the next number to decide what's going to happen here. So because that's higher than 5, that 4 is going to round up. And you can decide if you want to put zeros in front of here or not. You don't need them. But some people like to have them there. Sine 85. So let's go try our scientific calculator here. So this one, similar to the other scientific calculator we were using, we're going to go sine 85 and close off that bracket. Press equals negative 0.176. And because that's a 0, that 6 is going to stay as a 6. So cosine. We're going to use the cosine button. Same idea though, right? We're going to go cos 35. So know what calculator you're using and know how that works. So 0.819, and because that's a 1, that's going to stay at a 9. 29. And so see here, I did it backwards. It's not going to work. It gives me a little warning. So always check if it's giving you weird numbers or if things aren't really making sense. All of your decimals here should be smaller than 1. So cos 29, 0.999, and that 3 means that 9 is going to stay. Oh, that was cos 2. We're going to try that again. 29. Oh. Cos 29. That makes more sense. 0.874, but because the next number is a 6, that's going to round up. Cos 85. 0.087, and that 1 means it's going to stay. So part of today's lesson is just getting used to using those calculators. So whether your calculator puts the number in first or the cosine in first. So there's two ways. Remember, there's two things we use these ratios to find. First, you can use them to find a side, which is what we were doing here. We would use this if we were looking for a side. We can also use them to find angles. So for the angles, we call these the inverse functions. And so the sign that it's an inverse function is this little -1 that sits up top here. So if you're looking at the calculator on the right now, I don't see that button. And that's because for a lot of calculators, we're actually going to start with the scientific calculator I have here. Your inverse functions actually sit on top of the regular functions. So if we look really closely at the sine button, notice up top in blue here, we see that sine -1. And if we look at cos, we see the same thing. We see that cos -1 and that tan -1. So when they're sitting on top of the buttons, we call that the second floor or the shift. So to get there, depending on what calculator you're using, the button's going to be different. So on this calculator, there's a little blue second button. That blue second button will get me to the blue functions. So if I want to find the angle, I'm going to have to use this inverse function. So usually we have to start with the second shift button first. So we're going to go second. And what that does is it makes it so that when I click sine, what I'm actually clicking is the number on top. So I'm actually, or tan, because we're doing tan here. I'm actually clicking that -1. So we're going to go tan -1 of 0.466. So we're doing the inverse tan, and that will give me an angle. .436. That doesn't make sense. Hold on a second. Okay, so I just got a number here that didn't really make sense. My angle should be a whole number, and I'm not quite sure what that is. So I start to problem solve, right? We're going to start looking at what's wrong with my calculator. So I notice up here it says radian, and that's when we're dealing with trigonometry, this is going to be a problem you might have where you're getting numbers that doesn't make sense. Our calculator should always be in degree, DEG. If they're in radian or RAD, that's a problem, and we got to change that. So we're going to have to, so I'm just going to pause this for a second and fix it. Okay, so for this calculator, I had to go to mode, and when I go to mode, notice that it has options, radian and degree. I'm just going to switch that, so we're going to go down to radian and flip that over to degree. Okay, so now, quit that. When I do this, we're going to go again, so we're going to go tan, second floor tan to get the angle, 0.466. And that gives me 24.9, which is more what I'm looking for, right? I should be getting a whole number here. So that means A, so the number here, what we call theta, that is the angle I'm looking for. So here I'm looking for A, here I'm looking for F. So A here, my angle is 20, and usually we put these to a whole number, so 24.9 would round up to 25 degrees. So tan 0.183, so to find an angle, I have to use the inverse. So let's try this one. So on this calculator, I'm going to go to function, and function is going to show me the next level, my next set of buttons. So I see my inverse functions here. So I go tan, -1, and then I go back to my numbers, 0.1833. So it's 10.3. So we're going to leave that here at 10 degrees. And let's try that last calculator, my Desmos, or my computer calculator here. So on this one, and this is actually a really common way for it to be shown, we see an up arrow. The up arrow is very common as a way to show that we're going up. The most common being the second floor and the arrow. So we're going to go up, and then we see that tan -1. Oh, this is the calculator where I had to do it backwards, though. So we're going to have to go 3.025, and then we're going to go to that inverse tan. So A is 71.7, so we're going to round that up to 72 degrees. Okay, so same thing with sine here. So once again, because this one's backwards, we're going to have to go 602. And then this one where the button stays set, most of the time it won't. Most of the time you have to click it every time to go up. So here, F, angle F, is going to be 31 degrees. And so here, we're going to go function. We're doing sine, so we go to sine. And then we're going to go point. F equals 87, and it's 0.4, so we're just going to leave that at 87 degrees. And this little degree up here just means that we're talking about an angle. Just like a unit of measure for temperature would be like Celsius, or measurement would be meters. And so for our last calculator, we're going to go second floor. That means that we're going up, and we're going to sine. So I see that sine -1, 0.819. So 54.9 is going to round up to 55 degrees. And we can do the same thing with cosine here. So we're going to go second floor cosine, and it'll give us the inverse of cos, 0.765. So 40.0 is going to stay out of 40. So for this one, we're going to go function cos, 0.345. It's going to be 69.8, which is going to round up to 70 degrees. And on our last calculator, remember we're doing that second floor cosine, 0.248. Remember, you can close the bracket or not. It's not going to change your answer. 75.6 is going to round up to 76 degrees. Okay, so that's our calculator work. So why does it matter? Why do we need 3 of them, right? Like, why can't I just use tangent or just use sine? And it's because the relationships depend on what sides we know, whether I know the opposite, the adjacent, or the hypotenuse, because I need two of them, right? And when we write a ratio, we're going to write that as a fraction. So box over box is how you see it on a lot of on Word if you're trying to write a fraction. So if I'm using sine, I need so remember for a triangle, let's say I'm looking for this angle. This is my hypotenuse, this would be opposite, and this would be adjacent. So if I'm looking for sine, that means I know opposite and hypotenuse. If I'm looking for cosine, adjacent and hypotenuse. And tangent is opposite and adjacent. So we use the one we need based on what we know. So for this one, if this is the angle I'm looking for, my hypotenuse is always going to be the same, right? Across from the box, across from the 90 degrees. Opposite is going to be opposite, adjacent is going to be connected, right? So if I'm looking for sine, we actually use what we call SOHCAHTOA. You hear that a lot. So, meaning sine, is opposite over hypotenuse. Cosine, is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. So if I'm looking for sine here, I'm looking for right? Opposite over hypotenuse. So my opposite is 15, so we go 15 over hypotenuse is 25. For cosine, that's adjacent and hypotenuse. So that's going to be adjacent over hypotenuse. So adjacent being 9, hypotenuse being 25. Tangent is TOA. So that's opposite over adjacent. So 15 over 9. Now, if you know all three sides, you can pick whichever ratio you want, right? Because we have all of the information we need. When it becomes a little trickier is when we only know two, and we have to pick the ratio which has the right information. We're going to talk about that next day. So here, sine, remember, is so. So we're looking for opposite over hypotenuse. So we need to know what the sides are. Hypotenuse is always going to be across from the right angle. And adjacent and opposite depend on the angle I'm looking at. So because I'm looking for this angle, opposite is going to be across from it, and adjacent is going to be connected. So sine, opposite over hypotenuse. So opposite here is 4, hypotenuse is 19. Ca is adjacent over hypotenuse. So that's going to be 12 adjacent over my hypotenuse, which is 19. Tan is going to be OA, so 4 over 12. So everybody said it doesn't matter which one you choose. So we're actually going to test that here. So we're going to look at this last example. We're going to see what answer we get for both of these. Remember, we're looking for angle A. So what answer do I get for angle A? So the trick we need to get the decimal, right? That's what we learned before. So we would go 4 divided by 19. You don't need to know how to do this yet, because I'm going to show you when we do it next day. So sine A here is equal to 0.2105. And I have the whole thing saved there. So if I want to find sine A, that's my inverse function, right? So I'm going to go inverse second floor sine. And I'm going to use my answer button, which calls up my last answer that was on my calculator. So I get 12.2. 12 over 19, which is my cosine. So it kind of looks here like we might get different answers because we have different decimals. Remember, these are different ratios. That's why I have different ratios. So we're going to go cosine of my answer. Oh, that should be 4. No, 12, 19. So what I've actually proven here is that this triangle is not a right triangle because these two numbers should be the same. And the fact that they're not tells me that someone put random numbers on this triangle as opposed to actually using the right numbers. I bet you that 19 squared is not the same as 4 squared plus 12 squared. So what does that tell us? This is not a right triangle. So this doesn't work. But theoretically, these should end up being the same ratio. And we'll do some tests next day to see if that's true. So you guys are going to do the worksheet that is handed out today.